right, if there are two equilateral triangles, this is going to be always because, let me draw that a little bit better. It's going to be always because if you had, these are the same in an equilateral triangle, when you blow that up, whatever you have to multiply this side to get to this, you'd have to multiply this side to get to that, and this side to get to that. So these will always be similar. Two right angles would be sometimes, and the reason why is you could draw one right angle like this, a right triangle, and you could draw one right triangle like this. These are obviously not similar, but sometimes they will be, because you could draw a larger triangle than this with a scale factor, multiply this side to get something, multiply that to get the other side, and multiply by the same factor to get that side. So this would be sometimes. Two isosceles triangles, again, is sometimes, because you could draw one isosceles triangle like this, and you could draw another like this. These are obviously not similar, but they're both isosceles. So this is just sometimes. A scalene triangle, two scalene triangles, this would be sometimes, because you could draw one scalene triangle like this. This is scalene. And then you could just multiply this by a factor to make it a larger size, and multiply each one of these by that same factor, and you'll end up with two similar triangles. So this is going to be sometimes, but it's not always, because you could also have another scalene triangle that looked like this. Two squares. So if you have one square that's like this, and in a square all sides are the same. So if you make a larger square, you'd simply multiply this by a factor to get to this, but this multiplied by that same factor is this and this and this. So this is always. Two rectangles would be sometimes, because let's say you drew a rectangle like this. This is one rectangle. Another rectangle might be drawn like this. These are obviously not similar. So it's not going to be always. This is sometimes. Two rhombuses. This is not always. This is sometimes. Because let's say you drew a rhombus like this. Okay? And then you drew another rhombus like this. Those are two rhombuses, but they're obviously not similar. But it is possible to draw two different size rhombuses that are similar. So this is going to be sometimes. An isosceles trapezoid. Well, it is possible to draw two different size isosceles trapezoids that are similar, but you can also draw them not similar. For example, you could draw one like this with this side short, and you could draw one like this with the sides long. Those are two isosceles trapezoids, but they're not similar. So this is just sometimes. Two regular hexagons. Well, if they're regular, then all sides are the same. I'm not drawing this very well probably, but these are all the same. So if you drew another one where all sides are the same, they're going to be similar. Because, oh boy, that's a pentagon. What did I just do? Let me undo this. Whatever you multiply this side by to get to this side, you'd have to multiply this side to get to this side, and the same factor would be multiplied all the way around. So these will always be similar. I hope this is obvious. Two regular polygons. Polygons mean any two sides. So in other words, one regular polygon could be a square, and another regular polygon could be a equilateral triangle. Those are obviously not similar, but you could draw them similar. Like I could draw another square. These two are similar, these two are not, so this is sometimes. A right triangle must have a right triangle in it. An acute triangle has 3 acute angles in it, no right triangle, so these can obviously never be similar. An isosceles triangle has 2 sides that are the same. A scalene has no sides are the same. So this can be never, because if you had 2 sides that were the same, and then you had something like this, even if you were able to multiply this by something to get to this, if you multiply this by the same factor, you are going to get the same length, and you don't have it here. So this is never. A right triangle and a scalene triangle. Well, a right triangle, you could draw it so that the 3 sides are all of different lengths, making this a scalene. So a scalene triangle, you could have 3 sides that are that same length. Well, I guess I could just say that this could be a scalene triangle. So this is going to be sometimes, it's not always, because you could have drawn a right triangle that looked like this. And then that's not scalene because this and this are the same. But sometimes it is a scalene triangle. Okay, if a triangle is equilateral, it is also equiangular. So any equilateral triangle is an equiangular triangle, so this is always. Because we know that these 2 quadrilaterals are similar to each other, find 2 corresponding sides. And so 28 corresponds to 35, so these are, the scale factor is 28 to 35, which you reduce by dividing by 7, so you get 4 to 5. This is number 15. Number 16, what type of quadrilateral must this be? Well, if these are right angles, that means this is parallel to this. So if these are similar, this is parallel to this. So if the bases are parallel, this must be a trapezoid. And that's because T prime U prime is parallel to E prime N prime. T prime U prime is parallel to E prime N prime. All right, number 17, if this is 135 and these are similar, then this is also 135. Number 18, well, this is a trapezoid, so these 2 are supplemental. So if this is 35, then this is 45. So this is also 45. Number 19. Okay. We want to find UN, which is this right here. All right. And we'll call that X. These are similar. So the ratio to get from one to the next is, this is 28 to 35. So this is 35 over 28. That's the scale factor, which is dividing this out by 7, we get 5 over 4. So if we took X and we multiplied by 5 over 4, we would get to 15. So X times 5 over 4 is going to be equal to 15. So to solve for X, we're going to multiply by 4 over 5, and we'll do that on both sides. Over here, this obviously all cancels. So we're going to have X is equal to, and then over here we're going to cancel, and we have 5 goes into this 3 times. 3 times 4 is 12. So UN is 12. Number 20, oops. Okay, this is 16, and we want to find T prime U prime. So 16 times our scale factor of 5 over 4 is equal to this right here. We'll call this y. So 16 times our scale factor of 5 over 4 is equal to y. We'll cancel here. 4 goes into this 4 times, so y is 20. And that's what t prime u prime is. So t prime u prime is 20. Okay, so this side corresponds to this side. So we're going to say 15 over 20 is equal to, and if we want to find x, these two are corresponding. So this is the smaller side. So this is going to be 21 over x. Now, if you don't want to do the big cross multiplication, I can divide and divide by 5. So this is 3 over 4. And now I can cross multiply, and I'll say 3x is equal to 4. This is 84. So x is equal to 3 goes into 8 twice with 2 left over. 3 goes into 24 8 times. So x is 28. Okay, so I'm going to do the same thing for y. I'll say 15 over 20, that's these two corresponding sides, is going to be equal to this side corresponds with this. So we're putting the smaller one on top. So this is 18 over y. And again, I'm going to cancel this. 5 goes into this 3 and 4 times. So when I cross multiply, I'm going to get 3y is equal to 3672. I'll divide by 3 and I'll get y is equal to 24. Finally, to find z, I'll do 15 over 20 is going to be equal to, we're doing the smaller side over this side, so 27 over z. And then I'm going to cancel. 5 goes into this 3 times, into this 4 times. You know, you can actually, when you have proportions, you can cancel across the top and across the bottom. I'll show you that. So I could have said 3 goes into this once and into this 9 times. If you don't realize, you don't have to do that. But when you cross multiply now, we're going to get 1z is equal to 36. Now, the reason that works is because pretend I didn't cancel that way. I would have still had this 3 here and the 27 there. And then when I multiply, I'm going to get 3z is equal to 4 times 9 is 36. And then when I'm sorry, it's 26. 4 times 27, excuse me. So I have 4 times 27 is 108. And then when I divide, I get z is equal to 36. It was easier for me to cancel here instead of dividing this out. So I'll get z equal to 36. Okay, this side corresponds with this side. So that's my first ratio. I'll have 12 over 20 is equal to, now, if this is 60, the smaller side is 30. So if this is 90, this is my 60, and this will be my 30. So x, actually I don't even need the ratio here. X is going to be equal to 30. To find y, that corresponds to this hypotenuse. So I'll say 12, the short leg, 12 over 20 is equal to the short hypotenuse over the longer hypotenuse. And again, I'm going to cancel before I multiply to keep my number smaller. 20 goes into this once and into this twice. So when you're canceling, you can either cancel straight up and down within a single fraction, or you can cancel across the equal like this and like this, but you cannot cancel diagonally. Anyway, now when I multiply, I get 1y is equal to 24. Okay, I'm going to start with the givens. This is the short leg on the small triangle. This is the short leg on the long triangle. So 12 over 20 is equal to, now I'm after z, which is the long leg on the bigger height, on bigger triangle. So the bigger triangle is on the bottom. The long leg of the smaller triangle is 12 root 3. Now I'm going to cancel before I cross multiply. 12 goes into this once and into this once. So now when I cross multiply, I get z is equal to 20 root 3.